In this video, we are going to continue working with absolute value, only now we are going to be considering absolute value inequalities. All right, let's do a little warm-up. This will give us the opportunity to practice some of the things that we have already learned and see how they apply to what we're going to do now. So if you remember from before, when we solve absolute value equations, we are finding distance away from zero, and so we have to allow for two possibilities. Either my quantity 2x minus 3 is 7 units to the left, or my quantity 2x minus 3 is 7 units to the right. All I know is that it's 7 units away from zero. I don't know in which direction, so I have to allow for both possibilities. So if I solve this one, all right, my 3's are going to cancel there. 2x equals negative 4, dividing both sides by 2. X equals negative 2. Okay, let's solve this one. So if I put in 3, adding that to both sides, this time I'm going to get 10. Divide by 2, x equals 5. So I'm not saying that negative 2 and 5 are equal distances away from 0. What I am saying is that when I substitute in negative 2 right here, so if I did that, 2 times negative 2 minus 3, well, that is equal to negative 7, and negative 7 is 7 units away from 0. All right, let's see what happens when I put in 5. 2 times 5 minus 3, that equals positive 7, and positive 7 is also 7 units away from 0. So it's not that my answers are the same distance away from 0, it's that what happens when I substitute them in are both 7 units away from 0, one to the left and one to the right. All right, let's do a graphing question, and then we're going to put these two things together. So this first one, you guys see, it's an OR. And remember, when we see OR, that means anything that is in either one of them. So let's solve the one on the left, subtracting 3 from both sides, working to get x by itself, dividing by 2. I get x is greater than 4. There's no need to flip the sign here because I am dividing by a positive number. So I know all the things that are bigger than 4 are going to be in my solution set. Okay, let's do this other one over here. Now, I notice with this other one, I'm going to write it over here so I have some more space. I have a fraction. First thing we want to do is clear out that fraction. So I look at the denominator, which is 2, and I'm going to distribute a 2 across that whole fraction. I'm going to multiply everything by 2, whether it is a fraction or whether it's not a fraction, because my goal is to get rid of the fractions. 4 times 2 is 8. 7 times 2 is 14. Over here, the divide by 2 and the multiply by 2 cancel out, and I get 1x, which is the same thing as just plain x. All right, so I'm going to subtract 8 from both sides, and I get x is less than or equal to 6. Okay, so this is an OR question. I want to graph all the things that are greater than 4, which means they're going to go this way. I also want to graph all the things that are less than 6, which means it's going to go this way. So remember, OR means anything that is in either one of them. So anything that makes x is greater than 4 true needs to be in my solution set. At the same time, anything that makes x is less than or equal to 6 true is going to be in my solution set. Well, all the things less than or equal to 6 are here, and all the things greater than 4 are here. And so what I end up shading is the whole line. The answer to this one is all real numbers, which you can write out the words all real numbers, or you can use this little symbol. That is the symbol for all real numbers. And I believe that's what they have in Delta Math, is that they have the symbol for all real numbers. So the answer to this inequality, this compound inequality, is all real numbers. Okay, let's see what happens when we put those two things together. So now I'm going to have an absolute value like we had at the beginning, and I'm also going to have an inequality. So I don't know what my quantity negative 8a minus 3 is, but I know it is more than 11 units away from 0. So think about this. Here's 0. Here's 11 units to the right. Here's 11 units to the left. So more than 11 units away from 0. That's going to be all of these things. They're more than 11 units away from 0. And also all of these things. Those are more than 11 units away from 0 as well. So think about what I have here. I'm saying that the quantity negative 8a minus 3, if it's going to be over here in this area, it is going to be less than negative 11, or the quantity negative 8a minus 3, if it's in this area, it's going to be greater than 11. So notice what happens over here. When you do the negative part, you have to flip the inequality because I'm graphing on the opposite side of negative 11. I want to be more than 11 units away from 0, which means I need to be further to the left, which means I need to be less than negative 11. The positive one stays just like you think it should. It's just the negative one that flips around. Okay, let's solve this. So I'm going to add 3 on both sides here. Negative 8a is less than negative 8. Negative 11 plus 3 is negative 8. And I'm going to divide both sides by negative 8. All right, I divided by a negative. What do I have to remember to do? I have to remember to flip the inequality. A is greater than 1. Okay, let's solve the positive one. So I'll add 3 to both sides just as before. Negative 8a is greater than 14. Dividing both sides by negative 8. So again, I'm going to flip the sign. A is less than, and 14 over negative 8. 8 doesn't go into 14 evenly, but I can simplify. Both of them are divisible by 2. I get 7 and 4, and a positive divided by a negative is a negative. So I'm going to say less than negative 7/4. Okay, so here's 1 on my number line. Here's negative 7/4 on my number line. Okay, now this is only true for absolute value. This is obviously not true all the time because the one I just did is going to be different than this. If they are pointing away from each other, it's an or question. And if they are pointing toward each other, it is an and question. So A is greater than 1, that's going to be pointing this way. And A is less than negative 7/4, that's going to be pointing that way. So this is an or question. So greater than is going to be an open circle because there's no equal to line right here, right? It's just greater than. So it's going to be an open circle, greater than, shades to the right. And then for this one, it's the same thing. It's just less than, no equal to. So I'm going to put an open circle here, and I'm going to shade to the left. Less than goes left. So that is the answer to my inequality. And if I were typing this into Delta Math, what I would want to put is A is less than negative 7/4, or A is greater than 1. Remember, when you type in or questions, you do not put it all together. Those stay as two separate things, and you put the word or in between. All right, let's try the next one. In this one, I have a number with my absolute value. So do you guys remember what we did when we were solving equations? First thing we had to do was isolate the absolute value. We had to get the absolute value by itself before we could split it into two pieces. And the same thing is going to be true here. Okay, so let's look at this one, less than 1. So here's 0, here's 1, here's negative 1. Both of those are 1 unit away from 0. And I want all the things that are less than 1 unit away from 0. Well, on the positive side, that's going to be here. All of those numbers are less than 1 unit away from 0. And on the negative side, that's going to be here. All of those numbers are less than 1 unit away from 0 as well. So look at this negative 1. Do you see that on the negative 1, we shaded on the right-hand side? That means we did a greater than. So, oh, that's a terrible looking plus. V v plus 5 is greater than -1 because I'm on the right-hand side of -1, and v plus 5 is less than +1 because I'm on the left-hand side of +1. All right, if I solve both of those, v is greater than -6, and over here, subtracting 5, I get v is less than -4. Okay, so let's put those on our number line. Here's -6, here's -4. So greater than -6, that's going to go this way. Less than -4, that's going to go that way. So this must be an and question. Remember, with only true with absolute value, if they're pointing towards each other, it's going to be an and question, which is what they have in common. So all the values that are greater than -6 and less than -4 are shaded in, open circles on both because there's no equal to. And then you remember when we write an and answer, we write it as one inequality. That v is in between -6 and 4, just like I have here. It is less than -4, and if you look at this one backwards, v is greater than -6. If -6 is less than v, v must be greater than -6. All right, let's try this one with a fraction. Nobody's panicking though. We know how to get rid of fractions, right? We're just going to multiply by 7 on both sides. So on this side, the 7's cancel out. Absolute value of 3 plus r is less than or equal to 35, multiplying by 7 on both sides. Okay, now remember how we did this. The positive one doesn't change. 3 plus r is less than or equal to 35. The negative one, you have to remember to flip the sign because we're shading on the opposite side. So to solve it, I'm going to subtract 3 on both sides. R is greater than or equal to -38. Subtracting 3 on this side, R is less than or equal to 32. Okay, let's put those on our number line. Here's 32. Here's -38. I'm going to have closed circles on both of them, right? Because you see I have that equal to line, so I'm going to have a closed circle on both. Okay, let's see if we can figure out if this is an and or an or. Greater than 38, that's going to go this way. Less than 32, that's going to go this way. So what do you guys think? Is this an and question or an or question? If you said and, you are correct. This is an intersection. This is what they have in common. So and intersection, or you remember our intersection symbol that looks like the rainbow? All right, and we get ready to write our answer. -38. Look, the pointy part is to the 38. Less than or equal to r, which is less than or equal to 32. Remember, when you write and solutions, you write it all together as one inequality with the r in the middle. All right, one more. Let's try this one. Okay, I see that 8 has to move first. I have to get the absolute value by itself before I can do anything about splitting it into two pieces. Oops. Greater than or equal to 9. Okay, so now when I split it into two pieces, the positive side stays just like it was. And the negative side, I need to remember to flip my inequality the opposite direction. Okay, let's solve the negative one. I'm going to add 7 on both sides. -9 plus 7, -2. Divide by 4. R is less than or equal to -1/2. I don't need to flip the sign because the number I'm dividing by is positive. All right, let's solve this one. Add 7 to both sides. Divide by 4. Greater than or equal to 4. All right, so here's 4. Here's -1/2. Less than -1/2. Greater than 4. What do you guys think? And or or? Well, this is an or question. I'm going to need a closed circle on both of them because I see the equal to. less than shades left, and greater than shades to the right.